Hello class, welcome to our lesson today dealing with section 2.4. This section deals with special pairs of angles, so we're going to go over some definitions and some example questions to help use those definitions in our geometry class. The first definitions that we need to be comfortable with, which we've already talked some about this semester, are complementary and supplementary. What you'll notice here is we used an if and only if statement. So two angles are complementary if and only if the sum of their measures is 90 degrees, and similarly, if and only if they're 180 for supplementary. This goes both directions then, since it's this biconditional statement. So if two angles add up to 180, then their angles would be considered supplementary. When you're looking at the definitions, you just want to make sure that you know complementary and supplementary. However, you need to remember those is fine. Just make sure that you know complementary adds to 90 and supplementary adds to 180. Another definition that you need to know is dealing with vertical angles. So two angles are vertical if the sides of one angle are opposite rays of the size of another angle. So if you look at this example here, we have these two lines or four rays that intersect at this middle spot. Angles 2 and 4 would be considered to be vertical angles, and angles 1 and 3 are also vertical angles. So notice they go kind of in opposite ways of each other. A byproduct of that is that vertical angles are congruent. That's one of the theorems in your textbook. There's a proof about why that is the case, but it's a pretty simple proof if you understand supplementary and angle addition. For example, angles 1 and 2, measure of angle 1 plus measure of angle 2, they make a straight angle or add to 180. The measure of angle 2 and the measure of angle 3, they add to 180. And then you can just kind of set them equal to each other using substitution and then subtract angle 2 out from both groups. And you'll end up with angle 1 being congruent to angle 3 or their measurements being equal to one another. But remember, vertical angles are congruent is something that you would be able to use as we move forward in this semester. A lot of the rest of the questions that we're going to deal with are some example questions. So what I'm going to do is leave this up on the screen, give you a few minutes to see if you can figure out how to answer the question, and then I'll put up a solution to be able to see what the answer is. So let's take a few minutes and answer this question here using the measures below. Find the measure of each angle 4, 5, and 6. Okay, let's go ahead and go through this question here. The key is the ratios are given to you as 2 to 5 to 3. And so probably the easiest option here is just to make sure that you have a equation then at that point. So just make x the kind of the multiple of the ratios. So you have 2x plus 5x plus 3x equals 180. You solve for x by dividing by 10 because there's 10 numbers there on the left. And then you get x equals 18. Make sure when you're solving a question like this, though, that you answer the question. So you're supposed to find the measure of each angle. So you want to make sure that you do that by plugging 18 back in. So 18 times 2, 18 times 5, and 18 times 3 in order to figure out the measures of those angles. Notice also that I put measure of angle 4, not just angle 4. That would be something else that you want to make sure you keep track of as you're looking at this situation. The next question says use the information below, find the measure of angle HOP and the measure of angle POT. The information given to you is that ray OP bisects the big angle HOT. And then measure of angle HOP, which is this top one, is 10 minus 3x. And the measure of angle POT is x squared minus 6x. Again, I'll give you a minute or two to solve that question, and then we'll come back and find the solution. Okay, for this question here, you should have done kind of a factoring idea. So for this scenario, these two smaller angles are equal to one another because of the bisecting nature of the ray that was given to us. So if we set those two expressions equal to another and solve for x, you should get x squared minus 3x minus 10 equals 0. So x equals 5 and x equals negative 2. The biggest thing here that you want to make sure you remember is to check your answers. So don't assume the positive one is correct, because in this case, the 5 actually does not work, because in the original expression, this 10 minus 3 times 5 would actually be a negative. And so the 5 does not work, but the negative 2 does. So x equals negative 2 would give you the correct solutions for those angles, and then you would plug that back in. And then you should get the correct answer then of, let's see, 10 minus 3 times the negative 2, which would be 16. And then the 4 minus that as well to get the negative, or to get 16 for positive 16, excuse me. I a little tongue twisted there. Positive 16 for both answers when you plug in negative 2. So make sure that you're answering the question, that you're finding a measure of angle HOP and POT. And then don't forget to check your answers in order to find that solution. The next question just says find the complement of an angle is 24 degrees greater than twice the given angle. Find the measure of the complement. Let's go ahead and go through this one together just to make sure we're clear on some things. Remember, the word is equal to. And so if we just call the angle x, so the angle that the given angle is called x, that means the complement of the angle would be 90 minus x, because the complement and its given angle should add up to 90. So 90 minus the original angle would be its complement, equals 24 degrees greater than twice the angle would be 24 plus 2x. This would just be an equation at this point to solve. X should equal 22. But then don't forget, we want its complement, okay? And so the given angle is 22, so we do 90 minus that, which would be 68 degrees. When you're looking at a question like this, the key is the wording of it and how it's set up. You want to make sure that you're looking at it from the right perspective, and make sure you get your equation set up as well. The next question says use the information below to find the measure of angle B. So it says angle A is a complement to angle B. Angle C is also a complement to angle B. The measure of angle A is 3x plus y. The measure of angle B is x plus 4y plus 2. And the measure of angle C, sorry, that's cut off a little bit, is 3y minus 3. Let's take a few minutes to see if we can figure out how to find x and y, and then find the measure of angle B using that. Okay, for this question, what should have happened is you should have had a system of equations, because A and B, okay, the fact that they are complements, you add them together to equal 90, and similar with B and C. So you should end up with two equations, 4x plus 5y equals 88, and 7y plus x equals 91. From those two, either do elimination or substitution. This one, substitution isn't too bad because you could solve for x pretty easily right here and substitute that in for the x in the first one. Either way, you should get x equals 7 and y equals 12. Okay, make sure that you are practicing that idea if you weren't quite sure about that, but realize that you could have done either version, elimination or substitution at that point. And then from there, you would find the measure of angle B by plugging in 7 for x and 12 for y, and you'll get measure of angle B equals 57 degrees. You'll notice here that my measure of has been cut off kind of by me being here in the bottom left corner. Just make sure measure of angle B is 57 degrees for that final answer for this question. The next question is a proof. So remember, we've been working on two-column proofs and using the information that we've already learned in order to make the proof. Part of your homework is going to be this question. So given the straight angle AOB, so think of a straight line, straight angle with the point O in kind of the centralized piece of your line. Then point C is not on AB. So somewhere point C is there, and then OD bisects angle OAC, and OE bisects COB. So realize what you're looking at is the rays that are there, and let's see if we can figure out how to make this proof work based upon the given information. And we're trying to prove the angle DOE is a right angle. So your goal here is, let's see if we can get a picture set up and then try the two-step proof, two-column proof for this scenario. So given the information there, see if you can get a picture set up, try the two-column proof in order to find that answer. So if you need to pause this to be able to make sure to write that idea down, and then you can start solving from there. Your homework will include the proof that we just talked about on the previous slide, and then page 52, numbers 2 through 35. A lot of those questions should go fairly quickly with solving for x and solving for some missing variables, so I don't anticipate a lot of those questions taking too long. And then don't forget to try the proof that we just mentioned. Have a good day, everyone.